Hi, sir.
Hello, Amy. How are you doing?
I'm good, thank you. How are you?
Very good, very good. So, how is the winter there in UK?
Um, the weather's really bad right now. It's raining, and
Raining.
there's some sleet, but yeah, not
Oh,
that cold now. The snow didn't set.
oh my God, sleet is really bad.
Yeah.
Here we have -10. However, we have some snow also, but it's kind of dry, so there's no chances of slippering or anything. It's pretty good actually.
All right.
Yeah. And how is the COVID situation?
Still escalating.
That's good.
Restrictions are still held in place. Schools are being held now until March. It was
Hmm.
February, so now they're holding it to March. It's
Oh,
yeah, it's
okay.
bad. What about
Really.
in Canada? Is that
The
school
same.
still?
Yeah, they are closed. Yeah. So online classes. It's kind of difficult for students to learn online because both are getting adjusted. Even teachers are getting adjusted to this
Yeah,
learning system, and students are also trying to do the same, right?
that's true. Yeah.
Yeah. Okay. So you were saying that you want to learn trigonometric, how to solve trigonometric equations, correct?
Yeah.
So I thought we'll begin from some concept because you already know how to solve trigonometric equations as you did it as a part of GCSE earlier, correct?
Mhm.
And now at higher level, there will be more difficult questions. So we'll try to attempt those questions, but in this video, I'll kind of bridge the gap. Let's recall what we have learned, and then we will take up some questions in increasing order of difficulty and concepts, which should be useful for you to solve any question from your book. That's the whole
All
idea.
right. Okay.
So looking into the type of questions you shared with me, I've actually only created 6 examples. And with these 6 examples, I'm sure you will be able to solve 60 questions from your textbook for sure.
Oh well.
Yeah.
That
So let
sounds
me,
good.
yeah. So let me just share with you the screen, and then we'll begin from there. Okay. So I hope you can see my screen, right?
Yep, I can.
Perfect. So the idea here is to learn the concepts of solving trigonometric equations. Now, as you know, that what is these sine ratios? Sine, cosine, and tangent are the primary trigonometric ratios. They are always defined in a right triangle. So this is the right triangle which I've shown you. And with reference to an angle, normally we say that this angle is theta. So sine ratio, which is sine theta, is the ratio of opposite side to hypotenuse. So I've written in short as SOH, right?
Mhm.
Cosine ratio is adjacent over hypotenuse, C is A over H, and tangent ratio is the ratio of the opposite side over the adjacent side. So SOHCAHTOA is a short term to just remember what these ratios are, and also remember that we are always talking about a right triangle. Now, this right triangle could be placed in quadrant 1, quadrant 2, 3, or 4.
Mhm.
Depending on in which quadrant the triangle is, sine values, cosine values, and tan values can be positive or negative, correct?
Right.
The ratio remains same. It is important to note here that the ratio of opposite to adjacent side or opposite to hypotenuse will remain the same. However,
Mhm.
since they are placed in different positions on a coordinate plane, as you can see here, we say that one of the axes is positive x-axis and the opposite side is minus x. So negative value of x will lead to all the parameters like cosine is the ratio of the x value over the r value. Cosine becomes negative in the quadrant 2 and 3, correct?
Mhm.
Because the value of x is negative.
Right.
Now the sine will become negative in quadrant 3 or 4 since the y value is negative, correct?
Yeah.
So that is how the ratio's value could change between -1 to +1. Maximum value could be +1, minimum can be only -1, correct? Since
Yeah.
these ratios are the ratios of a smaller side of a right triangle to the hypotenuse. They cannot be bigger than the hypotenuse. Very simple as that. And that makes the ratios between the interval of -1 to +1. Well, when I say theta angle is 0, then the opposite side is same as the hypotenuse. And when we say the angle theta is 90 degrees, then the Yeah, well, it's the other way. So when I say
Mhm.
that theta equals to 0, the adjacent side is equal to the hypotenuse. So cosine is 1, right? But if I say theta is 90 degrees, then the opposite side becomes same as the hypotenuse. And for 90 degrees, sine 90 is 1. So that is
Mhm.
how the values change, and the maximum could be plus 1 only, right? So you have learned few things, and that is that these ratios have a range from -1 to +1. If I give you a trigonometric equations, if I say, well, what is sine theta equals to 2? It has no solution, correct? Because
Mhm.
it cannot be 2. It has to be between -1 and +1, correct?
Yeah.
Now, you also can see that if you're only looking for the angle theta between 0 to 360 degrees, it means one full circle. Now, in one full circle, we notice that all these ratios could have two values maximum, right? Because in quadrant 1, all are positive. In quadrant 1, all are positive,
Yeah.
and in the other quadrants, one of them is positive.
Oh, so
That
only two
means
values.
for a positive value,
You can
sine
only
and
have two
cosine will
answers.
have two values, even
Right.
tan, correct? Similarly, for negative values, we see that in two quadrants, they have negative values, right?
Mhm.
So that means if we exclude the values like 1, -1, zeros, in that case, for sure, for any other value between minus and plus 1, for sine and cosine, we will have two answers.
Yeah.
If we are working in solutions within the domain of 360 degrees. Just a quick reminder, angle 360 degrees. What we are seeing is a movement which is counterclockwise as shown here, right?
Yeah.
Counterclockwise from x-axis back to x-axis. Perfect. Now,
Wait, just a quick question. If the domain like changed and like let's say it was 0 to like no, like 720 or something like that, how do you know how many positive answers there are? So with 360 we know there's only two positive solutions. So
okay,
how do you know if it was
perfect.
like
Good, excellent question. Let's take an example. Let's just write down that sine theta is equal to half, right?
yeah,
Without getting into details, sine theta is half really means that you're looking for two solutions. One will be in this quadrant because it
yeah,
is positive. The other one will be in that quadrant, correct?
yeah,
Now, if you say that the angle is between 0 degrees to, let's say, 720 degrees, correct? In that case, what you're also saying is that this circle, you have to go like this. One full circle is 360 and another circle. Do you see that?
mhm, yeah.
So you go two rounds. And when you go two rounds, you do find 4 points, two in quadrant one and two in quadrant two. So we have four solutions.
Oh,
Does it make sense to you?
yeah.
If you have a
That's
multiple,
nice.
if it is n times 360, for example, correct?
Yeah,
And if the value is between, I mean, as such, we have taken, correct? Then the maximum number of solutions for that value could be 2n.
oh, yeah. Because for
Correct.
360, it's two solutions. So anything times n, you just times it by n. Oh, okay.
So
Yeah,
those
yeah.
are the number of solutions which you do expect. Okay.
All right.
Now here's
Thank
a
you.
word of caution. I've been always, removing the terms sine theta equals to 0, +1, or -1. This is very important to understand. Any other value except for these within that interval. The reason is kind of like this. Let me just erase this and explain you that also, right? Let's draw a sine wave, right? There is a rough sketch. Sine or cosine is one and the same thing, right? So if I draw this sine wave, for example, and in that case, what do you notice? You notice that there is only one solution. Let's restrict our interval to 360 degrees, one wave, okay?
Mhm.
So in one wave, you notice that for sine, we have only one solution for +1. Do you see that?
Yeah,
And only one solution for -1. Is that clear to you?
yeah.
Now, let me see and draw another cosine wave here, right? So let me just draw a cosine wave. The only difference between sine wave and cosine wave is that cosine wave starts with the maximum. Is that clear to you? So I've drawn one wave. Perfect.
Yep.
So here also you notice that for the value, which is 1, we have two solutions, but for -1, we have only one solution. You see an exception? So in
Oh,
160-degree, only one solution. And here you will also notice that for sine equals to 0, how many solutions are there?
1, 2, 3.
1, 2, and 3. And therefore, you have to be slightly, aware of this, because when I ask for number of solutions, correct? In that case, number of solutions could be none, because I could say, what is sine theta equals to 2? So the number of solutions is none, correct?
Yep.
We're talking about the interval between, let's say, 0 to 360 degrees, correct? In that case, we could have none, one, two, or even three solutions. As you can see, my value could be 0. For sine theta equals to 0, within the interval 0 to 360, I have three solutions. You get the idea?
Yeah.
So be sure about it. The possibility of number of solutions is 4, 0, 1, 2, or 3 for a sinusoidal or a trigonometric function. Within
Right.
the interval 0 to 360, I'm talking about simple ones, correct?
Yeah, yeah. So with cos, getting 0, there's only 2 solutions, whereas sine has 3 solutions. Okay.
So making this sinusoidal wave helps you to just see the solutions, solve
Right.
this. This is kind of a question which will be solve the trigonometric equation without solving, right? By
Yeah.
instruction or by thinking, by logic. So that is how you can provide even the solution or the number of solutions for such cases. Is
All
that
right. Yeah.
correct? In many of our examples, we will take special triangles. This is a very important topic, considering special triangles. There are two special triangles which we should be always considering. One is 30, 60, 90 as shown here on the left side, and the other one is 45, 90, 45. So for a special triangle 30, 60, 90, the sides are as shown, 1 square root 3 and the hypotenuse is 2. And for a special triangle 45, 45, 90 degrees, the sides equal length of 1 and hypotenuse of square root 2.
Mhm.
Sometimes we do take square root 2 and make that as 2, multiplying everything by square root 2, right? We do that to avoid 1 over square root 2 in these solutions.
Rationalize. Yeah.
Correct. So that is the only reason. So quickly, can you tell me what is sine of 30 degrees?
Um, so O divided by H, so half.
Correct. So opposite over this. And in this case, sine of 45 degrees will be 1 over square root 2. So easily you can find the sine ratios and solve your equations.
Right.
Now, getting back to your question is sometimes we can have many solutions, correct? A
Mm.
calculator will actually give you only one solution, correct? It
Right.
will
Yeah.
say sine theta is equals to minus half. Correct. If I change my question and I say this is my question now, let me take a simpler question regarding this diagram. Let me take a question which is say tan theta is equal to, let us say, some value 7. Now I've purposely taken tan. Tangent ratio can have any value, any real number. Okay, it has no restrictions because tan is the ratio of two sides, adjacent and opposite, and any one of them can be greater or smaller. They could be equal also. So the tan function, as you know, is kind of like this, the graph of the tan function, all real numbers, right? So tan
Yeah.
ratio. And we also see that tan is positive in quadrant 1 and in quadrant 3, correct? Because in quadrant 1, both x and y are positive, and in quadrant 3, both x and y are negative. So if I have an equation tan theta equals to 7, how do we solve it? Well, if I use my calculator, I can say that theta equals to tan inverse of 7 and get my value. But this is only one value. How do I get
Right.
the second value? Correct? So that
Mm.
becomes a challenge most of the time. So clearly, we have to work out with the related acute angle. So what we do is that in any of our questions, when we want to find one solution, I mean many solutions, first we find the related acute angle. Once we get a related acute angle, so we know tan inverse of 7 will be some positive value as shown here, and that angle alpha is our related acute angle.
Yeah.
To find the other angle, we know that the other angle will be in quadrant 3, so I have to add 180 to that alpha to get the other answer. So
Mm.
180 plus alpha will be my second answer.
Right.
So likewise, I can get many solutions for any particular question. Is that clear to you?
Mm-hmm.
Okay.
Yeah.
Another important concept is that you may have 2 theta, 3 theta, or n theta in your question, not just sine theta. So in this question, for example, if I have 2 sine 2 theta equals to square root of 3, it really means, and we were looking for a solution between 0 to 360 degrees, right, in one particular cycle, then how many solutions will this have? Well, sine 2 theta means what? 2 theta means two waves within 360 degrees, correct?
Oh, right.
Frequency will be 2 in within the interval 0 to 360. Or you can say that the time period will be 180 degrees for sine 2 theta, correct?
Mm.
It will
Yeah.
repeat after every 180 degrees, right? And therefore, the situation is kind of similar as we saw earlier. And here you can see this will give us a positive solution. So we are looking for a solution in quadrant 1 or in quadrant 2. So what we can do here is find the acute angle, and remember, we have to go twice and we are looking for 4 solutions. Is that clear to you?
Mhm.
As shown here by the arrows. We'll get into these details also. The last and most important thing, which is very critical to understand, is difficult questions where we have the argument, which is kind of like here, example, cos of 90 degrees minus 2 theta equals to square root 3 over 2. Looks like simple. However, the domain will now drastically change because the argument is 90 degrees minus 2 theta.
Mm.
How do we get solution of this kind of a question, right? So, well, as I told you, the best part is to find the related acute angle. Related acute angle is the angle which is always considered for a triangle being in quadrant 1, and the angle which the principal uh, angle which is from the x-axis, principal
Yeah,
angle,
yeah.
less than 90 degrees. Okay, so now what do we do? Let us say the question was to find the solution within the interval 0 to 360 degrees. We have to adjust this interval and then solve the equation. Now, we are looking into 90 degrees minus 2 theta, correct? Well, whenever it is given like this, it's a good practice to factor this, right? So we'll factor this as minus 2 theta minus 45. So factor minus 2, so you get theta minus 45, correct?
Yeah.
Now, domain was given to you between 0 to 360 degrees. The related domain will be what? First, you subtract 45 from each, so you get minus 45 is less than equal to theta minus 45 is less than equal to 360 minus 45, that gives you 315. And then you multiply each by minus 2. When you do so, you have to change the inequality sign, which has
Oh.
been now changed to greater than. Therefore, you're looking for all the other values which are between 90 degrees to minus 360 degrees. You get my idea. Once
Mm.
you find those answers, then you try to get the angle theta. We'll look into these examples also, which will be one of our examples. Okay, out of those six.
Okay.
You get the
Yeah.
whole idea.
Yeah,
That
yeah,
is
yeah.
the spectrum which we are looking into, and that should help you solve each and every question from the exercises which you have shared with me. Okay?
All
Sounds
right.
good?
Yeah, sounds
Great.
great.
One more thing, we'll also talk about trigonometric identities. Here is the list of trigonometric identities which you know, kind of. I'd like you to keep this as a record. Take a picture of this page. That should help you to solve many trigonometric equations. Okay. So we are saying quotient identity is tan theta is the ratio of sine and cosine. Cotangent, these are reciprocal trigonometric ratios. The most important, which we are going to consider in today's lesson, is the Pythagorean identity. Three of them, sine square theta plus cos square theta equals to 1, 1 plus tan square theta equals to secant square theta, and 1 plus cotangent square theta equals to cosecant square theta. You should also know that sine is an odd function, right? And cosine is an even function. So sine of minus theta is minus sine theta, and cos of minus theta is cos theta. Is cos theta. Okay, so correct. Fine. Well, these Pythagorean identities which you see here can be rearranged and written in many different forms. So sine square theta plus cos square theta is 1. You can always write this as sine square theta as 1 minus cos square theta. You could write cos square theta as 1 minus sine square theta. You could also factor, right, 1 minus cos square theta. You can factor as 1 plus cos theta into 1 minus
Yeah.
cos theta. And so in different ways, you could use this particular identity. Now, Co-function identity is another very important concept. Co-function really means that we are looking at the right triangle. Let me just draw one here to make things absolutely clear. Let's say this is our angle theta. So if I'm talking about the sine ratio, which is opposite over hypotenuse, I am saying this is sine ratio opposite over hypotenuse, correct?
Yeah.
Now, let us see, what is this angle on the other side? How much is this angle? Well, this angle clearly is 90 minus theta, right?
Yeah.
Now, for 90 minus theta, what is cos of 90 minus theta? Can you tell me? Cos of 90 minus theta is the ratio over h, correct? Because that becomes the adjacent side. So what you notice is that cos of 90 minus theta is same as sine theta. And that is what is called
Oh,
function identity. So
I
it
see.
reverses, right? Similarly, sine of 90 minus theta will be cosine theta, and tan of 90 minus theta is cotangent theta. Very important identity to be applied. Is that okay? So,
Yeah.
so we'll be actually using these identities a lot, right? So that's why it's a ready reference material for you. Now get ready. Here are the questions which we need to solve. So these are the 6 questions which we'll solve one by one. Okay.
Okay.
Starting with the very basic one, which is question number 1, which says square root of 3 sine theta equals to cosine theta. You can always divide by cos theta. You get tan theta on the left side and 1 over square root 3. We are always, the question is, Amy, can you read this question, please? All from you.
Solve the following trigonometric equations in the interval 0 to 360 degrees.
Right.
Write the exact value or round answer to one decimal place.
Correct. If you are using special triangles, you have to write the exact value. That is what the question is saying. But if you are using a calculator, round your answer to one decimal place. Correct? So that is what we are doing. So in many of our solutions, there will be some answers which will be like exact values and some will be rounded because we might have to use a calculator to find the
All
solution
right.
for the other factor. So while writing your
Yeah.
answer, you have to be careful in this particular case, right? So these are the 6 questions. Have a good look at it. Now let's begin with their solutions and relate to the concepts which we began with. Question number 1 here is very simple. As I said, square root of 3 sine theta equals to cosine theta. We are working in the domain 0 to 360 degrees. Perfect. So what we will do here is we'll divide just by cos theta. So we get sine theta over cos theta. We can take square root 3 on the other side. So you get 1 over square root 3. You will be reminded of a special triangle which is 30, 60, 90. Here, we have the term square root 3, right?
Mhm.
So sine theta over cos theta from trigonometric identities and also from basics, is tan theta. So tangent theta of 1 over 3, tan is the ratio of opposite over adjacent. So all these things come together. So when you begin answering, just remember, SOHCAHTOA, these ratios, and now tangent theta is 1 over square root 3. You are looking for a triangle, right triangle, which is a special triangle 30, 60, 90. The ratio of 1, opposite side is 1. That means you're looking from angle theta. Opposite side is 1 and the adjacent is square root 3. And therefore, we get one of our answers, which is 30 degrees. Clear?
Yep. Mhm.
Now, the second thing which you have to look into is the quadrants. Tan theta is positive, correct? So positive means the answer will lie in these two quadrants, quadrant 1 and in quadrant 3.
Mhm.
Get both the answers, which we have to report. We already have one of them, and one of them is 30 degrees. The
So
other
you
one
add
is
180.
you have to add 180 degrees. And when you add 180 degrees, you get 210 clearly. So we have 30 plus 180, and you get 210 degrees as your answer. So that is how you give all possible answers within the given domain, which is 0 to 360 degrees. Is that clear to you?
Yep.
Perfect. So to begin with, that is our basics. So you learned how to use special triangles, the quadrants, and the interval 0 to 360 degrees. Question number 2 here is, can you please read this question number 2?
Yep. So 5 sine 3 theta minus cos 90 minus 3 theta equals 2 within the domain 0 to 360.
Perfect. So we kind of jumped 2 levels at this particular stage.
Yeah.
So that is what I meant to say.
It went from easy to hard real quick.
Real quick. So
Yeah,
that only then you can do 60 questions from your book, you know.
fair enough.
So I just wanted to make you comfortable. Now let's get into it.
All right, let's do it. We love a challenge.
First part, 90 minus 3 theta reminds you of co-function identity, correct?
Yeah.
You remember cos 90 minus theta should be sine theta. So first step is to simplify this. So cos 90 minus 3 theta will be sine 3 theta, correct? All of a sudden,
Because yeah,
right?
because when you said cos 90 minus theta is sine theta, so if there's a like a 3 something or n theta, you just put that value with the sine and
So
vice
that is
versa.
called complementary identity.
Oh,
Cos of 90
okay.
minus theta is sine theta. So that is why I introduced you to this identity. And all of a sudden, this question, which looks so difficult, has become a very simple, like a tamed question, right?
Yeah,
So we got
that's
to
good.
5 sine theta minus sine 3 theta equals to 2. So simple as that. You get the idea. But the idea here is to
Yeah,
use identities in the right way. Otherwise, you get scared of these questions, right? So it
right.
wasn't fantasy. So you just combine 5 minus 1 is 4. So 4 sine 3 theta is 2, sine theta is 2 over 4, which is half. And clearly, for half, we have our special triangle. Is that clear to you, right?
Yeah,
You're looking for sine. Sine is the ratio of opposite to hypotenuse. And clearly, from here, this is your opposite side. That is your hypotenuse. So the angle theta should be 30 degrees. In this case, 3 theta. The argument is 3 theta, not theta, correct?
right.
So we'll write 3 theta equals to 30 degrees. We have our first solution. How do we find other solutions within the interval 0 to 360 degrees is our challenge. Well,
Mm,
we know it is positive, and therefore we are looking for all the solutions within quadrant 1 and quadrant 2, correct?
yeah.
Second part is that it is 3 theta. 3 means 3 circles, right? So we go 1, 2, and 3. 3 circles means these are our solutions. Solutions are 3 solutions in quadrant 1 and 3 solutions in quadrant 2.
Perfect. Yeah.
We got the first one, which is 30 degrees. To get the second one, we know it is 180 minus 30, correct?
Wait, so how did you get that?
Because this is this angle, right? So the total is 180, right? In quadrant 2, the related acute angle is 30. In quadrant 2, the related acute angle is 30, correct? This angle is 30, correct?
Yeah.
So principal angle is what the solution is, which is from here to there, right? So it is 180 minus 30. Let me let me redo it. No problems. So first step is to find the related acute angle, and we found that related acute angle as 30 degrees. Is
30.
that clear
Yeah.
to you?
Yeah.
We used our special triangle to find the solution. Of course, sine theta is positive in quadrant 2 also, so we have the second solution lying in quadrant 2,
Yeah.
where again we know that the related acute angle is with the horizontal, right? It is 30 degrees. So what is the principal angle? Well, the principal angle right from here to there is what? It is 180 minus 30.
Oh, yeah, yeah.
Is that clear to you?
Mm-hmm. Yeah.
So with that, we get two solutions for the first circle, right? Right? But
Mhm.
between 0 to 360 degree, since our argument is 3 theta, our argument is 3 theta, right? We have to go 3 times. That means we have to add 360 each time. You get the idea?
Oh, yeah.
Add 360 to 30, you get 390. Add 360, you get 750. To 150 also, you have to add 360 and 360 to get the other two answers,
All right. Yeah, yeah, yeah. That makes sense.
right? Another
Mhm.
important thing is you have to look into the domain. It was given to us for theta between 0 to 360 degrees. For 3 theta, you have to multiply by 3. It becomes up to 1080, right? So from 0 degrees to 1080, that is what our range is now. So therefore, for 3 theta, we are looking for all the values, which are between 0 to 1080.
Mm.
Now you can divide by 3 to get the value of to get the value of theta. That will be our answer. So
Right.
dividing each by 3, we get 10, 130, 250, 50 degrees, 170 degrees, and 290 degrees. Since we use a special triangle, we are providing you with the exact solutions, right?
Yeah.
So you have
That's
learned
clear.
the concept of change of domain in this particular case, and you have also visualized the same by saying that, well, in this particular case, what really happens is this, that 3 theta really means three circles, 1, 2, and 3. And that means six solutions, three lying in quadrant 1 and three lying in quadrant 2. And that is how we get six solutions. Do you see?
Hmm.
I hope that helps, right? Now let's take question number 3. Is this concept clear to you, Amy? Moving
Yeah.
on. Perfect. So you also learned complementary angle and simplified that difficult question looking so easy, right?
All right.
Now let's look into that type of question once again. And now, can you please read question number 3?
Yeah. So 12 cos 2 theta minus 10 equals minus 3 within the domain 0 to 360.
Correct. So first thing this time, we'll approach from the domain part. We are
Okay.
given the domain theta as between 0 to 360 degrees, but we are actually interested in the argument, which is 2 times theta minus 10. So we
Yeah.
have to work on the domain. So first part is minus 10. So you do minus 10, minus 10, and minus 10 to all the three things. And
Hmm.
the inequality now becomes minus 10 is less than equal to theta minus 10, which is less than equal to 350 degrees. And now we have to multiply by 2. So when you multiply by 2, the inequality or the domain for us will be minus 20, which is less than equal to 2 times theta minus 10, which is less than equal to 700 degrees. So when we are trying to find the value for the angle 2 theta minus 10, we have to write all possible solutions within this modified domain. And that's what I
Right.
say, that the domain gets modified when the argument gets modified. So we'll finally get the answer between 0 to 360 degrees. Okay, it's
Hmm.
kind of a transformation. Okay, now let us see what happens. Well, simple as that. I'm going to divide minus 3 by 12, and once I do that, I do get cos of 2 theta minus 10 as minus 1 over 4.
Hmm.
Since cosine is negative, I know we are looking for two solutions, and these two solutions which should be in which quadrant? Tell me, Amy. Negative
Um,
cosine value.
quadrant 2 and 3. Yeah.
Perfect. Quadrant 2 and 3. So, and then we're also looking for 2. That means how many solutions?
Um, 1, 2, 3, 4.
4 solutions, 2 in each quadrant.
Yeah.
And the idea is to find the related acute angles first. So first step is to find the related acute angle. That means forget about the sign. When we talk about related acute angle, we are looking for the solution when theta is positive. Is that clear to you? So we
Yeah.
call this angle as alpha. So clearly what I've done here is written cos alpha as 1 over 4. I've dropped the sign negative. We'll take care because we'll find the answers for quadrant 2 and 3 placement.
Mhm.
Correct?
Just a quick thing.
Yeah.
With related acute angles, is it always with the x-axis,
Yes.
wherever it is? Okay, cool.
Wherever
Yeah,
with the x-axis, and it
cool.
is same, right?
Hmm.
Vertically opposite angles are equal. That gives you the concept. Okay, so cos alpha equals to 1 over 4. Use your calculator. Cos inverse of 1 over 4, you get the answer 75.5 degrees. So we know this angle alpha for us is 75.5 degrees. Now, we are looking for the principal angle from here to there, right? In quadrant 2, it is going to be 180 minus 75.5. And in quadrant 3, it is going to be 180 plus 75.5. Is that clear to you?
Yeah.
So we actually add these two values with plus and minus 180, and get our solution. So 75 point, so our argument actually is 2 theta minus 10. So 2 theta minus 10 should be equal to what? 180 minus 75.5, that gives us 104.5,
Mhm.
right? And 180 plus 75.5 gives us 255.5.
Yep.
Now, that is the first circle. The second circle is 360 degrees addition. So
Oh, so you
add
add
these
360.
values, 360.
Oh,
You
I
get
get
the
it.
edges. And
Yeah.
then you get the other two.
That's quite straightforward. Yeah.
How you get everything? You could begin from anywhere. It is
Mm.
visualizing the solution, right? So you can
Right.
see the argument, the domain, get to the quadrants, see how many solutions you are trying to get, find the related acute angle. That is the first step. And now you know you're looking for four solutions. You should be adding 360, 360, and get the other 2 points, correct?
Right.
And related acute angle gives you the two solutions in the first circle, right? So I'm not saying between 0 to 360, but I'm saying a circle, right?
Right.
One
Yeah.
wave, one wave. 2 theta means two waves. That is what 2 theta means. So two waves to give me four solutions. And then it's a matter of readjusting, simplify, divide by 2 first, then add 10
Add
and get
10.
your
Yeah.
solution. Simple as that. Done, right? Let's move on and take up the next question, which is question number 4. Now, we have, can you please read this question?
Yeah. 2 sine square theta minus sine theta minus cos square theta equals 1 between the domain 0 to 360 degrees.
Correct. Now we have mixed up terms. We have sine and cosine. To
Yeah.
find an equation, it is a good practice to write it in only one trigonometric ratio. So we will split sine square theta and write this in terms of sine square theta. Use
Mhm.
trigonometric identity, right? Cos square theta
Yeah.
plus sine square theta is 1. And therefore, we know sine square theta, cos square theta is 1 minus sine square theta. So I'm
Yeah.
going to replace cos square theta with 1 minus sine square theta. Simplify. Once you simplify, you get 3 sine square theta minus sine theta minus 2 equals to 0. Is that clear to you?
Yeah.
And that is a simple quadratic equation factor. Product of 6, sum of minus 1. So I split the center term into minus 3 theta plus 2 sine theta. And then we factor. When you factor the first two, you can take sine theta common. And the second one, you can take 2 common. So you get two different factors. One is sine theta minus 1, and the other one, the remaining, 3 sine theta plus 2.
Would
And
you
both
mind
are,
explaining? Sorry,
yeah,
would you mind explaining the so after the 3 sine square theta minus sine theta minus 2 equals 0,
yeah,
how did you get the next step after that one?
sure.
Kind of lost you on that. Yeah.
Okay. So that is a quadratic equation. Remember quadratic equation?
Yeah. So a squared. No,
Okay. Right.
that
Ax
one. A
squared
squared.
plus bx plus
B.
c times, right? So in this case, whenever you have such a question, you have to find product.
And so.
Product should be AC and sum. Sum should be B, correct? So in
Yeah.
our case, the product P is 6, which is 3 times 2, minus 6 rather. And the sum is minus 1. 3 times minus 2 is minus 6.
Yeah.
And so we are looking for two numbers whose product is minus 6 and sum is minus 1. The numbers should be minus 3 and 2. So when you add them, you get minus 1. So I
Oh.
split this minus sine theta with minus 3 sine theta plus 2 sine theta.
Mm,
Now,
yeah.
now I can factor in steps. In the first two terms, group factoring. In the first two terms, I can take 3 sine theta common. I'm left with sine theta minus 1. In the other two terms, I can take 2 common and I'm left with sine theta minus 1. And now I can take sine theta minus 1 as a common factor and I get 3 sine theta plus 2 as the other factor. Is that clear to you?
Yeah.
Perfect.
Hmm.
And both should be equal to 0 because 0 times anything is 0. So the possible number of solutions we will get when we equate sine theta minus 1 to 0. That gives me sine theta equals to 1. Only then sine theta minus 1 will be 0.
Right.
Right? The other factor, 3 sine theta plus 2 is 0 when sine theta equals to minus 2 over 3. Correct?
Mhm.
And so we are looking for now solutions for sine theta equals to 1. As we explained earlier, sine theta is 1 when theta is 90 degrees when you are working in the domain 0 to 360 degrees.
Yeah.
So we get one solution. For the other factor, we have a negative value. Negative value really means we are looking for a solution in quadrant 3 and 4. We'll actually find the related acute angle using a calculator, right? Alpha. In this case, alpha is sine inverse of 2 over 3, 41.8. The other two answers will be what? Well, one answer is 180 plus 41.8, And so we get one answer, which is 221.8, right? And the other one will be 360 minus 41.8. So we get the other solution as 318.2.
See, I lose you at those parts. Like, so I understand when you get the acute angle, it's just getting how I don't know when you add 180 and when you add minus
Simple.
360.
Simple. I mean, look
Yeah.
here. This is your angle alpha, correct?
Yeah.
Now, our principal angle is the angle from here to there, correct?
Yeah.
So, how much is this angle? Well, to angle alpha, I added how much? I added 180, right?
180.
Is that clear to you? 180 plus alpha.
Yeah. But if that alpha angle was on the other side of that green line,
Okay. You
would you
could
still
think
add
like this.
180?
You could think like this also. Let me do it like that. Let me do it like this. So this is angle alpha. That really means that this is also angle alpha, right?
Yeah.
Now, principal angle is starting from here to there, right?
Yeah.
180 plus alpha. It is sum of alpha and 180 degrees, right?
I don't know why I can't picture this.
Well,
So
this,
I get that it's a line and that's 180 degrees, but I, I don't know.
okay, so this is 180, right?
Yeah,
And
that
that
makes
is
sense.
alpha. When you add them, how much do you get?
180 plus the alpha.
Yeah, that is what I'm writing.
Okay, okay. So that makes sense. So then, okay, fine,
The
fair enough.
other one, let's look into the other one. No problems. Other one. So other one is, let's see, this is the other one, right?
Yeah.
The other one is, we know this angle is alpha, right? All the angles, related acute angles are alpha. So we're looking for angle from here to here. It is 360 less alpha, right?
Oh, so 360 minus the alpha. Oh, okay. I think I see it better when you write the related acute in the
Other
other
places
area.
also, right?
Yeah.
So
Yeah.
alpha is everywhere, right? With the horizontal line. Think like
Yeah.
this.
Okay.
Is that
Yeah.
clear
Yeah.
to you?
Yeah.
So,
Yeah.
yeah. So we get actually those two solutions, correct? Now, uh, that gives us three in all, 90 degrees from the first factor and the other two. See, the other two have been written rounded to one decimal place.
Okay. Yeah.
Good job.
Cool.
Question number 5. Can you please read this question?
Yeah. So 4 sine theta cos theta minus sine squared theta plus 4 cos theta minus sine theta equals 0.
Yeah.
So between the domains 0 to 360 degrees.
Perfect. So another good example, we'll just club the terms, simplify them. We do see it's a quadratic equation, so we need to factor. So once you see a question, the strategy should just get into your mind, flow in. So clearly, we can just club these two terms, right? When you club these two terms, sine theta is common. You are left with the factor 4 cos theta minus sine theta.
Yeah.
And you can also club these two terms. Well, nothing is common. Just put them as one factor. How?
Okay.
You find this is a common factor. 4 cos theta minus sine theta.
Oh,
Take
yeah.
that common. You're left with sine theta plus 1. And that should be equal to 0. It really means what? It means that sine theta plus 1 should be equal to 0. And, each factor should be 0. And 4 cos theta minus sine theta should also be 0 to get all possible solutions.
Right.
If sine theta plus 1 is 0, sine theta is minus 1. And as you know, that is possible when theta is 270 degrees, when we are talking about the interval 0 to 360 degrees. Is that clear to you?
Yeah.
So always keep the sine wave in your mind, right? So that is the sine wave, which we are always looking at. And when we say minus 1, we're looking for this value, correct? Which is 270 degrees, correct? This is 0, this is 360, correct? This is 270. Is that clear to you?
Yeah. There's only one solution. Yeah.
Only one solution. So
Right.
that is our first solution. Now, 4 cos theta is minus sine theta. That is equal to 0. Rearrange. So when you rearrange, you get 4 cos theta equals to sine theta, right? And then you divide by cos theta. So you get sine theta over cos theta equals to 4.
Yeah. Which is tan theta.
Tan theta equals to 4.
Ah, I
Use your
see.
calculator.
Right.
And of course, this time I didn't draw the quadrants. Tan theta is positive, You're looking for two values, one in quadrant 1, the other one in quadrant 2. When you do cost inverse of 4, you get one answer, which in this case is alpha. The other angle alpha is here. So the
So
two
add
solutions
180.
are add 180. This time I
Okay.
knew how should I explain it. I've understood.
Yeah, yeah, I understand it. That's so clear. Okay.
So we get two
Thanks, sir.
solutions, alpha and 180 plus alpha. Right. I'm
Yeah.
learning. I'm learning. Good job. Absolutely clear, right? It's flowing
Yeah,
in.
so clear.
Yeah.
Yeah.
Last question here. So the last question actually is kind of a test question for you. So what I've done here is written this in a quotient form. So we have question number 6, sine 2 theta plus 0.5 divided by 1 minus sine 2 theta equals to 2. Again, we are working in the interval 0 to 360 degrees. You
Mhm.
need to solve this question. Now, Amy, many times when this question comes, you may be expected to write restrictions also. Can you tell me what is the restriction for this equation?
Mm,
Denominator
is it,
cannot be 0. So 1 minus sine 2
um,
theta cannot be 0. That means that sine 2 theta is not equal to 1, correct? That means that 2 theta is not equal to 90 degrees or theta is not equal to 45 degrees. Is that clear to you? So the restriction is that theta is
mm,
not equal to 45 degrees. You should keep that in mind when you solve. Sometimes the questions are so tricky that one of the solution is 45 degrees. I mean, that restriction.
I
It's called
see.
an extraneous route. So, right? So that could be an extraneous route. So you have to be aware of this. Okay.
Yeah.
So keep that in mind. The question is not asking for, but anyway. So simple way to solve this is cross multiply. In any equation, you can cross multiply. So when you cross multiply, you get 2 times 1 minus sine 2 theta. Open the bracket and simplify. When I open the bracket and simplify it, I get 3 times sine 2 theta equals to 1.5. It's a very simple equation you can see, right? Not
Yeah.
difficult at all. And sine 2 theta is 1.5 over 3, which is half. That means I could use my special triangle, which we used in first example, right? Half is angle is 30 degrees. So within this interval of 0 to 360 degree, we will get rather two solutions. However, we have sine 2 theta, right? 2 theta means
So
what?
you have to divide by 2. Yeah.
Two circles, correct? So two circles. So we have four solutions. Again, a reminder. So positive value. So we have solutions,
From
four
there.
solutions in quadrant 1 and 2. So we are looking into the domain. 2 theta should be between 0 to 720 degrees. So to
Hmm.
this angle, which we got as 30 degrees, we got the first answer as 30 degrees. We'll find the other acute angle. So once again, let me draw it the way you see it. All right. So we have this angle, which is alpha. This is also alpha. So what is this angle? The other angle is 180 minus alpha, right?
Yep.
In this case, 30 or 150 degrees. So we have two solutions, 30 and 150 degrees, correct? To
Then
get
you
the
just
other
add.
solutions, because the second circle we have to go through, add 360 to both,
Yeah.
1 by 1, and you get the other two solutions. You were expecting 4, you got 4. And these are your 4 solutions. Divide by 2 to get the value for theta. And that becomes your
Perfect.
answer for the given question.
Yeah.
Is that clear to you?
So clear. Can't believe
Very
you covered a lot.
okay.
Yeah.
So, Amy, could you revise or just summarize what you've learned today?
Yes. So we kind of started off just with the basics, this page showing what we were going to cover in the lesson. And we touched upon all of them. So yeah, like we showed, it kind of started off quite straightforward, and then it obviously got harder from there. But the thing is, like Sir said in one of the things, if you use the rules, which is was on the next slide that you had a whole like PDF.
Identities.
Yeah, identities. If
Yes.
you just use these appropriately where the question requires it, it makes the question so much easier.
Yes.
So if you could go to question 1, I'll just like kind of summarize each one about the points that I learned.
Yes.
So yeah, in this one, it's quite straightforward really, just using the cast rule, making sure you've got the domain that they've asked for in your head, what we're looking for, and using your special triangles here. So that was all that was learned in this question. Then here I learned about the complementary identity. So knowing that cos 90 minus theta equals sine theta, and then vice versa, and how when the question says that, the domain has changed, so you have to be aware of that. So it says 0 to 360, but when it happens where the domain has changed, because it said 90 degrees minus 3 theta in this case, you have to be aware of that when finding your solution. So I think the best thing about this one was, I kind of asked in the beginning, how do you know how many solutions you are required to get when the domain changes? Because with 0 to 360, we know there's only 2 solutions. So by drawing that diagram, I feel like with the circle, when you draw one wave and then you draw what you want, and if you do another circle like that for the second wave, the points where it crosses the lines that you want, it allows you to show exactly how many solutions are required. So yeah, if you put the dots, for example, so in this case, it was 3 theta, so we've got 3 waves, so 3 times 2, you've got 6 solutions. So I think that was really good. Then question 3.
Correct.
Because being aware of the number of solutions would make sure you know you're like correct.
Yes.
For this one, yeah, we were talking again just about the domain changing, and it is the same principle, just I guess a little bit harder. And next one, it was, oh yeah, so here we were trying to make all the the subjects within the equation the same. So like you do in algebra when you have a try and like group the terms nicely. So we saw that cos squared theta can be made into sine squared theta using that equation of sine squared, the trigonometric identity. So you can easily rewrite that into 1 minus sine squared theta and then just work from there.
Perfect.
Same principle applies. And yeah, in this one, again, finding common groups. So we found that in the end, when you worked it out, you could find that 4 cos theta minus sine theta was a common group in both of them. So you can just factor it out and then solve. And where it says sine theta equals -1, whenever its values like 0, -1, or 1, just draw the sine wave and you can easily find out the values via that.
That's so true.
And question 6, what was that? Oh yeah, so this one about restrictions, being aware of the denominator, and if it's something that cannot equal 0, if you get a value that, like 45 in this case, you need to be aware that that is not a solution, so don't write that down because it's not valid with the requirements. So yeah.
So that is so true, right? So you beautifully summarized the whole lesson, Emmy, and I hope with this you should be in a position to answer most of the questions from your book. Now, what I also observe here while learning along with you, that we could actually combine the trigonometric identities and the trigonometric equations, and that results into some very challenging questions. So tomorrow we'll take up another exercise where we'll have combinations. I'll not give you a straightforward trigonometric equation. Rather, I'll give you a trigonometric identity kind of on one side. It's both sides. It'll be kind of combination of trigonometric identity and equation, and we'll see how to solve that level of questions, which will be very important for GCSE examinations, level A.
All right.
Right?
Yeah,
so,
perfect.
Right. So in case there is any difficulty, share with me so that I could incorporate those things also in tomorrow's lessons, Amy. Okay?
All right. So I'll just go through my book and attempt all the questions and see if I can do them now. I think I can, because we went through like a load of concepts in that time. So thank you so much, sir. I really appreciate it. And have a good rest of your weekend.
You too. Thank you.
See you tomorrow. Bye, sir.